Hello and welcome to our webinar, Optimizing the Product Development Process Through Prototyping, featuring our speakers, Taylor Foster, Account Executive for the Mid-Atlantic region, and Tom Walworth, one of our Senior Application Engineers. Taylor has a background in mechanical engineering and business, attended the University of Kentucky, and has been working in the manufacturing industry, specializing in injection molding consultation and education, as well as customer experience for the past 2 years. Tom has been with Eccentric for nearly 6 years and has supported hundreds of clients with their injection molding, CNC machining, and 3D printing projects. Tom provides project guidance ranging from design tips to material selection to ensure his clients' parts are manufacturable and meet their design intent. This presentation is expected to last approximately 45 minutes and is being recorded. There will be a Q&A session at the end of the presentation. Taylor and Tom encourage you to ask your questions throughout the presentation, and they will take time to answer them as they come in. Use the questions field on your screen to submit your questions. Follow Eccentric Mold and Engineering on LinkedIn so that you can stay up to date on our latest blog topics and webinar schedules. Also, follow Taylor and Tom, whose contact information is on the screen. I now turn over the webinar to our experts, Taylor and Tom. Gentlemen?
Hi, everybody. This is Taylor. Thank you so much for joining us today. I really appreciate you taking an hour, 45 minutes or so out of your day to join us and just have a conversation about product development and where kind of prototype tooling fits into that process and how it can be a benefit to you. So today we're going to spend our time really focused on you. We will definitely talk a little bit about Eccentric as well. And if you have any questions, obviously we're happy to answer those. But really today, again, we want the focus to be on you. So like Mark said at the beginning, if you have any questions, definitely feel free to ask them throughout. You don't have to hold them for the end. And we will have some interactive polling questions along the way as well, just to kind of get your feedback and thoughts as we're walking through this. So what we'll cover today, as you can see here in our presentation overview, we're going to start out just generally speaking a little bit about the product development and prototyping processes. Second, we'll dive into the time to market implications there. And then third, mitigating risk with prototype tooling more specifically. So 1, 2, and 3 are all going to be tied very closely together, you'll see. And then 4, again, shifting gears a little bit to the Eccentric side and how we fit into all of that. We will speak a little bit towards the end about how we can help you achieve those things, getting to market faster and mitigating your risk. If you could hit the next slide for me, thank you. Awesome. So the first topic here that we had for you today was just, again, diving into the product development cycle as we see it. Eccentric has been, assisting our customers just like you for about 23 years. And over the course of that time, we've heard a lot of things and we've seen a lot of things, as you can imagine. And as we kind of worked with and collaborated with different customers, we started to kind of figure out that there were a certain set of factors that typically drive a wedge into your product development process, which make it really challenging and sometimes hard, even from a planning perspective to get your products to market. So with so many pieces kind of working within that puzzle, for us, our focus and the focus today is going to be kind of on that development process and making sure, again, that you can get to market seamlessly. So to understand what issues really can arise, we have to kind of break down the process, right? We have to look at each step in the process and what could potentially happen. So we're going to serve you a quick question here. Mark's going to put it up on the screen for everybody, just around the most common challenges you face when you're getting new products to market. So you can see the options there. Feel free to select one. You've got dimensional or tolerance issues, material issues, lead time delays, changing in tooling, or something else. I'll give you a second here to select an answer. Just want to know what you think.
Okay, it looks like the votes have come in, so we will close that and share the results.
Awesome. All right, so it looks like the majority of people here are definitely experiencing one of 3 issues, typically speaking, either dimensional intolerance issues, lead time delays, or changes in tooling. And I think those are definitely very common. That's what we see a lot of times as well in our experience. So awesome. Thank you for answering that. And we'll dive into the next slide with that in mind. So hopping again deeper into the general product development and prototyping process as it exists, these specific phases have kind of been proven out and used for decades at this point to develop and produce products. And it starts with having an idea, creating a design, doing some virtual prototyping in an AutoCAD type software. Then you're going to move into physical prototyping. So that's your 3D printing type runs where you're just verifying the design, making sure everything looks good. Then you would typically move to pre-production, then validation and verification, and then you would move to full-on production, right? You're to market. And what we found here is that each phase is going to build on the last one. So each time you move to a new stage, you need to kind of generate additional information. You need to build on the last stage to be able to bring that high quality product to market with all of the correct standards. On the flip side of that, you also find that as these build on each other, if you run into something where there's a problem, if you find a problem, for example, at pre-production, you're typically going to double back a couple of steps to something like virtual prototyping, where you're going to change the CAD file versus hopping straight back into physical prototyping. So it is worth noting that not only do the phases build on each other, but if you make a mistake, it's not as easy as going back one step. So as a result, really prototype, the physical prototyping, and then prototype tooling can play a very critical role in this process in terms of reducing the risk of going backwards. If you could serve the next slide for me here, Mark. And actually, I think we have a polling question here. So if we can pull that up, awesome. So we have, when working through your product development cycle, when do you typically engage suppliers to discuss your tooling or molding for the first time? So one of those stages, you can see the different stages there for selection. Are you typically reaching out as soon as you have an idea? Are you waiting until design, virtual prototyping, physical prototyping, or pre-production? All right, and it looks like we have some results here. So typically speaking, it looks like the folks here with us today are typically engaging either at the design, the virtual prototyping, or the physical prototyping stage. And it looks like that the majority of people here engage at the physical prototyping stage. So that is really good information, and it kind of builds into our next slide as well. So we'll transition there. Awesome. So what we figured out, again, kind of building on the last slide, is that investing in prototype tooling can help you support the entire product development and launch timeline. And more specifically, our customers who are able to engage earlier in the process, more towards the idea, the design, the virtual prototyping phase, are going to experience better results long run, because that helps the vendor or the partner you're working with better support you in those most time critical phases, where you can go ahead and kind of pull out any problems you might run into. On the other hand, and on the other end of things, there are folks out there like us who are able to turn around projects in injection molding and prototype tooling that are extremely short lead times. So with that being said, even though some people were answering, all the way to physical prototyping, that's no big deal as well, because we're still able to kind of get in there, learn from what you've done so far via some consulting and advising, and then move from there. So that's really good feedback to know when everybody is typically engaging. We'll hop to the next slide here. Awesome. So now we're going to shift gears. We talked about the product development process as it exists, and kind of where we see maybe some changes could be made in terms of trying to get better results out of that process. And we're really going to kind of dive into that now with reducing your time to market and risk with prototype injection molding. So starting here, what our customers have really found over the course of working on many different projects and different points in the product development cycle, making changes and corrections earlier in the cycle. So at idea, design, rapid prototype tooling phases are much faster and less expensive changes to make. They can still get to market on time, is what that means. And on the flip side of that, the further along you get in the process before you figure out a problem, obviously the more expensive and more time consuming it's going to be. So you can see a graphic here that really kind of helps drive this home. If you're at the idea phase, I like to say, you've got an idea on a napkin, and you figure out you want to change that design, no big deal, right? You just crumple up the napkin, you grab a new one, you redraw it. It takes you a minute, maybe $1 to get a water that comes with with a napkin. So not a big deal. You move into design and you're working in CAD and you're actually fleshing this out and you want to make a change. It's going to take a little bit more, right? Maybe $10, 10 minutes to make a quick tweak within that software. Moving to rapid prototyping, so this is typically your 3D printing type of genre. You're going to see right around $100 or 100 minutes, maybe part of a day to fix a problem and create a new prototype. So still not a big deal at all. Same for prototype tooling, which is again kind of what Zentric is going to specialize in, typically speaking. You're looking at about $1,000 and maybe 1,000 minutes, so a week or so, to make those changes and be right back on track. You can see the really large jump that happens after that, though. When you move from prototype tooling to production tooling, and even more specifically, in that first product development cycle we talked about, some people would jump straight from rapid prototyping, skip over prototype tooling, and go to production tooling. What you can see here is why that is not a good idea, right? You're looking at just the jump from prototype to production, you're looking at tenfold, right? It's like an exponential scale here. If you find a problem at that production tool stage, you're looking at, and I've seen this time and time again, at minimum, typically speaking, around $10,000 for a tooling change. And you're looking at a very long period of time to get that change implemented and back on track as well. So if you're skipping over that prototype tooling phase, what you find is that you go from a place where it's very easy to kind of get back on track, and all of a sudden you find a problem, be it with moving from an ABS-like material to a true ABS thermoplastic or something else that causes a problem in your production tooling, and you end up losing both time and money that you could have avoided and could have stayed right on track with prototype tooling. So just wanted to kind of speak to that a little bit and give you guys some numbers and some hard data in terms of what that looks like. On the back of this, I want to ask you a question. So we're going to serve another poll here and see what you think. So have you ever discovered problems after reaching the production phase that required changes to be made? Simple yes or no this time, so not too difficult. Wow. Okay, guys. Well, that is staggering. So, you can see the results here. 100% of people on this call who are attending the webinar today said yes, they have discovered problems at some point on some project after reaching production that required changes to be made. So I would imagine that last slide I showed you was very, relatable. I'm sure you felt that in a very real way because you've experienced it. You've experienced what that takes at that stage. So that's really good information to know, and that's what we found as well. I don't know that I've talked to an engineer who hasn't faced that problem at some point. So thank you for your feedback there. Let's hop over to the next slide. Awesome. So on the back of all that, right, we've talked about kind of how it's traditionally been done in terms of the product development cycle. We've just talked about why the typical route may not be the best one. 100% of us have experienced problems with the traditional route, right, going to production and not pre-validating with prototype tooling. So what we've done and kind of what we've learned over the period of time we've been working with customers, we've been listening, and what we figured out is that there's an alternate way to approach this that's going to, again, save you time and money, right? And that's the top way. So the bottom here is, again, a more detailed version of what we were talking about earlier in terms of your typical product development process. And the top is kind of how it's been reimagined in terms of what we've heard from customers and how this should look in order to get to market and have the results they're wanting. So you can see the differences here, right? You're getting to production earlier. That's an important thing for a lot of customers out there because you're not, again, having to run into that production mold change, double back, spend $10,000 more, 10,000 more minutes at minimum to make that fix. You're having a very small period added in at the beginning. You can see here, prototype mold design, production tryout, prototype mold changes if we need them. They don't always even happen. And then you're moving into product pre-validation 6 weeks sooner than you would be if you went with the traditional product development cycle as it is currently done. So not only are you getting to market faster, but you're also feeling better as you move through that last period, right? You're feeling confident, your management, everyone involved in the project has confidence that this has already been proved out. This is an easy and smooth transition, and we're gonna get to market on time and kind of, perform the way you've planned. So this is a really powerful thing we found. Let's hop over to the next slide here. So driving this home, right? One of the things a lot of people are going to say to me, and it is going to be a fair point, is that production tooling and prototype tooling are not created equal, right? There's differences. There's reasons that you may want one or the other. So I think it's really important to understand what issues and what things you can avoid and can be uncovered with that understanding, right? That prototype and production tooling are not equal, but prototype tooling can tell you almost all of the same things that production tooling can tell you, and then you can make changes if needed at a fraction of the cost and time. So those things are going to be the ability to get feedback on dimensional issues for the part. So if you have critical dimensions, and again, you hop straight from 3D printing to steel tooling, production tooling, you're typically going to run into a scenario where something with a critical dimension is not quite right. That's a big problem. Also learn material behaviors. As we discussed earlier, going from an ABS-like material to a true ABS thermoplastic is going to behave quite differently. So you want to go ahead and figure out what that looks like at that prototype tooling phase. Along with that, you're going to be able to see things like shrinkage, warp, sink, splay, and other aesthetic problems. So you're not going to, again, get all the way to production. The dimensions are all right, but you have this nasty sink or splay in the part and it can't go to market. And then last but not least, not many parts out there exist in a vacuum. So what I mean by that is you want to be able to check it out within the final assembly and make sure that fit and function are going to work properly, not just for one part, but the entire assembly. So really important at that prototype tooling phase to be able to get all of those parts in hand, assemble them, make sure everything's working as it should be before hopping all of those different tools to the production side of things. So we have another question for you here. We're going to serve it up now. Does your company or organization currently use prototype tooling within your typical product development process? So another yes or no for you. Do you typically use it or do you typically not? Okay. All right. Here we have some results. So, the vast majority of folks on the webinar today, looks like 86%, are looking at a yes on this. So the vast majority of folks, listening to me right now and talking through this with me are already kind of bought in terms of an organization standpoint to the benefits of prototype tooling before moving on. So that's awesome. And for the 14% out there, there's a lot of folks that obviously have been in that camp, and obviously sometimes that's an organizational thing, sometimes that's a personal preference, but hopefully as a result of this, you can ask some questions that'll help you kind of clear up, once and for all for you if it makes sense or not. So I appreciate your feedback there. So hopping back in here, kind of tying this all together, right? We just talked about it. Do you do it or do you not do it? And the reason I asked that is, again, identifying and addressing these issues early, allowing your teams, your project managers, your bosses to de-risk the overall project and have enough time to react is only going to be good for everyone. Significant delays that you run into at product introduction as a result of production tooling errors are going to dig into your launch schedule. They're going to dig into your profit targets and your market share because other people are going to beat you there. And then I really say all that to say, and tying into that question, if you didn't answer yes, that's certainly okay. But my question to you would be, why risk what doesn't need to be risked, right? Why make that jump and have that pain point that 100% of us said we have if you don't need to? Is budget a good enough reason to skip straight past prototype tooling and be risking problems and more budget and pushing back your launch deadlines? So really want to kind of just drive that home and ask that question. And on the back of that, we'll serve another poll here. See what you think. So have you ever gotten through your design, your rapid prototyping, so you've done some 3D printing, and maybe even further, only to be told when you take it to somebody for molding quoting that your designs were just too complex to be molded? They can't help you. Sorry. How many of you have had that happen? Yes or no? Okay. Awesome. So here's the results. About 60% of us, a little over half here on the webinar today have experienced that pain point, have done a ton of work on the front end, gotten through, CAD and 3D printing, and maybe even other steps in the process just to be told, hey, so sorry, this ends here. We can't help you, and I think that's tough because obviously you've put in a lot of work to that, and it's good. I'm glad to see that 40% of folks here, so there's a decent amount of people who haven't been told that. So that's good. Maybe you're talking to the right folks. So that's awesome. Let's hop into the next slide and talk about why I asked that. So again, I kind of told you we would shift gears a little bit. I want to establish kind of who we are and what we do, so you know why you've been listening to me for the past 20 minutes or so, and why you'll want to continue to listen to us as an organization. First and foremost, as I mentioned at some point earlier, we've been in business providing manufacturing services to more than 50 industries for over 23 years. So we've seen a thing or two, as they say. Our manufacturing facilities, both located in Southeast Michigan, right near Clinton Township, if you know where that is. All of our molds are built and run there on site. So the molds are built there, the parts are run, everything is in-house here in the US, more specifically, again, Southeast Michigan. We have produced over 100,000 physical injection molds over the course of our time in business. And as you can imagine, millions of parts out of those tools. We offer thousands of different engineering grade materials. So just about anything you can imagine, we either keep in stock or can source for you if it's commercially available. And we do offer ISO 9001:2015 certs, as well as ITAR and UL. I know that's really important for a lot of our customers, either from a quality perspective or obviously a data security perspective. Whatever the case may be, we have resources to make sure you're taken care of there. Let's hop over to the next one here. Awesome. So a little bit more, and this is, again, shifting gears back to you, right? Why does this matter to you? So I talked a little bit about us, and I'm sorry, I know that's not always the most fun, but tying it back to you, right? Why does it matter to you who we are and what we do and how we view the product development process? Our value proposition, quite simply, and what makes us different than anybody else out there who you could work with on this stage of your process and throughout the product development process, are going to be three things, in my opinion. First, we are extremely fast. We are an industry leader out there in terms of lead times, and I don't know that I've ever seen faster, to be honest with you. So that's the first. Secondly, very flexible, very collaborative. We're more than happy to work within your designs. So asking that question earlier about have you ever been turned down because your project is just too complex, that's not something you're going to run into with us. We're not going to limit you on undercuts. We're not going to limit you on those sorts of things. We're going to work with you and make sure that we can achieve what your in need and goals are. Third, and certainly not last, is just quality. Again, the team's very experienced, and not only are we able to collaborate well, but we have a track record proven, again, across 50 industries, 100,000 plus molds in 23 years, that says we produce quality parts and you can count on us. So diving into the more the weeds here, so to speak, more specifics on those claims I just made, because I want to back them up and tell you how we achieve them and how we are different. In terms of the flexibility, so geometry is a big key there, right? We can mold simple and complex components, doesn't matter. We can do over molding, we can do insert molding. We do offer all of your standard surface finish options, so whatever you might need there, we can take care of. Complex laser texturing, laser etching, and then on the material side, so this is what allows us to be as fast as we are, we keep over 150 stock resins in-house for same or next day production. So that means if you had a tool with us and you wanted to cut a PO and get parts, we are able to start running those parts the same or the next day for over 150 different materials that you could need and are commonly available. Outside of that, as I mentioned earlier, any commercially available thermoplastic can be ordered or custom blended by us. So if you can find it out there and it makes sense within your design, we are more than happy to source that for you and take that kind of burden off your plate and work within that. We do, in some cases as well, have customers that need to supply their own materials. Some customers have proprietary blends, for example, that can't be found out there because they're only in-house. So if you do have materials that you would need to supply, we can accept that in the correct form. So that's something we can work with as well. And one more note here, custom blending colors, rather you need a very specific color, a generic color, all you have to do is give us, a marker such as a Pantone, and we're able to custom blend those for you as well. So hope that helps kind of drive home those 2 points on fast and flexible there. Let's serve one more question here. I'm gonna see what you guys think about the fast side of things. How important is it to you? So when you transition in your product development cycle to the injection molding side of things, how quickly do you typically need parts, right? When you're engaging with a vendor, is it typically gonna be, you need them a week or sooner? This is a 5-alarm fire. Is it gonna be 1 to 2 weeks? Is it gonna be 2 to 4 weeks, 4 to 8, or over 8 weeks? So let me know, how quickly do you typically need your molded parts? Okay. All right, so we've got a wide variety here. This is great, and this is again what we see across the folks that we collaborate with as well. Wide variety of needs. Some folks need 1 week or sooner. Wow, that is fast for molded parts. 1 to 2 weeks, again, very quick for molded parts, and a good 29% of us here fall into that category. The vast majority of folks at 43% is 2 to 4 weeks, so falling right in that kind of mid-range need in terms of lead time. And then 14% of us are on the long end of things, just kind of like on the short end of things. So we do have some folks with 4 to 8 weeks as well. Nobody over 8 weeks. So I think that's an interesting note, but this is really helpful. So thank you for that feedback. And let's transition into the next slide and kind of speak to that. So here at Zentric, we again pride ourselves on our speed. I mentioned earlier, and I want to back up, that we are an industry leader in terms of being able to get you parts when you need them. So for my folks out there who selected any option, I have news for you. We have an option for you, which is great. So you can see our standard here, our standard lead time, just kind of out of the gates, if you were to quote with us and not express any urgent need, would typically be somewhere right in that 13 to 15-day range. So that's going to be standard in terms of getting your tooling done and being able to start running parts. When you're looking at the 2 other expedite options, so we have an initial expedite level, which is going to be around a 10-day option, so taking around 5 days off of your standard lead time there is going to be an option for you. And for those of you, I know there was again 14% who said, yeah, I need to get parts within a week or faster. We do on many of our tools have a 5-day option as well, so you are able to get that tooling done. Make sure samples are right within a 5-day period and then start running those parts. So no matter what you just answered to that question, we have an option that fits you. And I think that's really powerful because I don't think that's the case across a lot of the rest of the industry. Secondarily, I want to mention here, again, back to the customer focus and the you focus, we do have a very intuitive customer portal on our website that you're able to log in and view your quotes and make these changes yourself. So when we create that quote for you, you're able to go in and toggle things like your lead time. You're able to toggle surface finish. You're able to fill in a number of parts you might want off the bat and see different quantity breaks right there in the website. Change cavitation, all kinds of options for you. So keep that in mind as well. Just a tool for you as you're exploring different options and have different needs. We do have something that fits that. Let's hop over to the next. Awesome. So getting into a little bit of the nitty gritty here. What do we actually offer, right? What are the offerings that we support our clients on day in and day out? You can see, obviously, and we've talked a lot about it, injection molding. So prototype injection molding, as well as low to mid volume production. We're a very good bridge partner that can kind of get you to your production phase and kind of stopgap that need in the meantime while you're waiting for that production tool to get spun up after we verified. So that is an area we can kind of continue to serve you after that prototype stage. We do have in-house mold design and production, as we mentioned. We work from very simple to very complex projects. And like I said, and I want to drive home again, we're not going to come to you and say, hey, this design's too complex, it can't be molded. We're going to mold to meet your project requirements. We're going to come back to you with helpful feedback that ensures that you're getting the best results. CNC machining, another offering of ours, 3, 4, 5 axis, small and large volume runs, comprehensive material offerings, and all the different finish and surface options that you're accustomed to. And then also additive manufacturing, so 3D printing, urethane casting, those sorts of things that give you the ability to test and build those complex geometries before you even move into tooling, so that you can get a good idea and a proof of concept, try out a variety of different, polymer or additive, polymer or metal, materials in that stage, and figure out what works best for you. So I want to note here, CNC and additive for us are really supplementary. Injection molding, as we've kind of discussed, and more specifically prototype tooling, are our bread and butter, but we do offer these other things because they are supplementary. They do build towards that and help support one another. So I think that's an important note. And across the bottom here, you'll see, just because you don't see it here on this slide doesn't mean we can't help you or can't offer it. We do coordinate processes and secondary operations for our clients with other partners of ours very frequently. So always feel free to reach out and ask Tom or I. We're always happy to help you and find some folks that could help you with whatever it is, regardless of if you see it here or not. Hop over here. Awesome. So I encourage everyone, I know engineers are very visual people, right? I'm an engineer. I like to feel and see and touch things. I want to know that, before I kind of get involved in someone, that they're going to make quality parts. So this slide is just to give you an idea, just show you a couple of parts, obviously, that we've made in the past, some varying complexities, materials, applications, obviously. And what I encourage you to do is check out the website, zentricmold.com. We do have a tab there on the website called Parts Gallery, and it is extensive. It has many, many more than the 6 you see here, obviously, but it's going to tell you what industry they were made for, what material they were made from, whether they were a simple or complex geometry, what process they were made in, all kinds of useful things for you to get a good idea of the quality of work we do and who we do it for. So I would encourage you to check that out when you get a chance. Let's hop over here. Awesome. So key takeaways today, and again, I want to thank everybody for joining and all of your polling answers, because that's an awesome experience for me to get to interact with you in that way and really get a feel for where you're at and how you connect with what we're talking about. And it's clear, based on the answers, you can really connect with what I'm talking about, because again, 100% of us have experienced problems at the production phase. We've all had that pain point. Most of us on this webinar are already utilizing prototype tooling. So you're already thinking about this the way that we're thinking about this, and that we think maybe you should, if you want to reduce your total project time, cost, and risk on your project. Again, we can help you. We specialize in those short lead times, the custom mold making processes, highly complex parts, and true collaboration, right? We're going to work with you. We're going to help you bring your products to market faster in a proactive manner, rather than the reactive manner you're used to in the industry. And last, again, we've been doing this for 23 years across 50+ industries, more than 100,000 molds under our belt. We are, at this point, no doubt, a premier provider of rapid manufacturing and consultative services, specifically a leader here in the United States. And our goal is to provide you a better solution from idea all the way to part. So again, appreciate everybody today for kind of hopping in and having inputs and being open to this conversation. And at this point, I think we're going to transition to kind of continuing it. But I'm going to let Mark pop up one more slide here that's going to have some information for you in case you would like to reach out. So Tom and I work directly with a business development rep here internally. His name's Brian Daly, very sharp guy. If you have any projects or upcoming needs you're working on right now, and you need something like NDA established with us, vendor docs completed, or you already have your CAD and inputs ready for quote, feel free to reach out to myself, Tom, or Brian. All of our information are here in the PowerPoint for you in the presentation. Or there is a Get Started link here at the bottom as well. I talked to you about the interactive quoting portal. Feel free to check that out and submit directly there as well if that's better for you too. But just know that we're here. We're a collaborative resource. Reach out to Brian, myself, Tom, if there's anything we can be doing to help on current or upcoming projects, and we'd be more than happy to.
All right, thanks,
Awesome.
Taylor. So as we said at the beginning, please use the questions panel on your screen to ask any questions. And Taylor, we have had a couple that have already come in. The first one is regarding 3D printing as a use of prototyping. Why can't I just use 3D printing as a prototype to prove out my design?
Yeah, That's a really good question. So I've done a lot of talking today. I'm going to let my expert here on the inside, my technical specialist, applications engineer, Tom Walworth, I'm going to let him take the floor here. I'm going to let him answer that. I think Tom might be on mute. Give us a moment. All right, I'll tackle this one. We'll get Tom in on the next one. Oh, Tom, you there?
I am here. Sorry about that. Mark had me muted over
No
there.
worries. Go right ahead, Tom.
So 3D printing. 3D printing is great for really, like you touched on, Taylor, early in the developmental process, getting something physical in hand to test. The first issue that we tend to see with our customers in 3D printing going to market or carrying on in low volume settings would be the scalability of the cost of 3D printing. Each one of those prints is going to hit you at a certain level, which may not be as competitive should you in the long term, essentially. Also, one of the drawbacks of the 3D printing process is the design restrictions or lack thereof as you transition into a longer timeline production. You may not run into issues with 3D printing certain features where when you get to your molder, like you touched on with your question, you're experiencing all types of problems trying to manufacture, whether it's, a die lock situation or, an unresolvable feature. Those are the issues that we tend to see with the 3D printing.
And thanks, Tom. And I also want to let everybody know we'll send out a link to a white paper that talks about this. Eccentric actually sees 3D printing and injection molding as complementary parts of the same process. So we'll send out a link when we send the recording out so that you can all have a chance to read that. Next question is, what are the typical design flaws that you see that actually cause problems in molding?
Yeah, for that one, I would say that the number one design flaw or thing to focus on is going to be wall thickness. Wall thickness is going to be the root of so many potential issues that you could run into with molding. We really strive for a consistent nominal wall thickness with parts. That's going to ensure even cooling on the parts and help you reduce any warp or sinking. When you have uneven wall sections on a part, you're going to get uneven cooling, which is what's going to cause that sink. Now, we realize that you can't always achieve that with your geometry. So our best bet is to take a look at each individual part and advise, where we may see potential issues. So there's a great importance for support ribs on larger parts and even smaller parts to ensure that you're not running into those issues, but you want to follow the rules of your rib to nominal wall thickness ratio. You also want to go by the material guidelines for each material type that you're going to be using, because a suggested nominal wall thickness is going to not be the same using a glass-filled polycarbonate as it would be using a polypropylene. So material is definitely going to play a role in that as well. So I would say that is probably the number one issue that we see and talk about daily with part designs.
We have another question. Any plans for ISO 13485 certification for medical devices? And I can take that one, guys. I know at this point we don't have any immediate plans for that. It's been discussed, but we have no immediate plans for it.
And to speak to that a bit further, I think where medical companies are typically finding us to add value in their process is again in that prototyping phase versus the production phase where you're needing a clean room type application. So it's a really good question.
All right, next question. How does Eccentric help me transition what we learn in prototyping to my production tooling?
Sure. So like Taylor touched on in the presentation, there's a lot of value that can be gained with prototyping the tooling, which it sounds like most everybody is doing for the most part here. Finding out where you're going to see those potential cosmetic issues, the sinking, where you might run into trouble filling a part. We like to be very collaborative and engage with you on the front end as early as possible with the design and go over project intentions, because we may not necessarily design a prototype tool the same way if you're going to be running 10,000 parts for the year, or you plan to take this to a production molder to run millions of parts a year. We want to simulate on a lower scale the type of tooling that will be going into production. So whether it's automation versus manual, or certain gate configurations, we want to do our best to replicate that. It's also not uncommon for us to work with the production molder as that project transitions to full-blown production. So we're happy to share our findings with your other supplier as far as, you know, how the tool was designed, how the tool ran, what processing parameters were used, so they can kind of avoid the first steps and trial steps that we help to establish.
All right, I see right now, I see two more questions. So folks, if you have any other questions, please be sure to enter them into the questions pane. The next question is, what are the typical tolerances for your tooling?
Sure. So eccentric standard tolerance is going to be a tool tolerance. So our standard tool tolerance is going to be plus or minus 0.005 to the CAD model after factoring in the shrink rate of the material that we'll be using. So that's something we talk about daily as well, and how to achieve tight tolerance parts. So something that we recommend is going to be, and I'm sure most everybody has heard the term, but a tool safe approach to the tooling. That's ensuring that any changes that need to be made with the tooling are going to be removing material from the tool itself. So if you're talking in terms of the physical plastic part, adding it's always going to be easier to add plastic to the part as opposed to take it away. So, you know, if we're talking about a feature such as a tight tolerance through hole, we would ask that you oversize the through hole. So that way, once we sample the tooling, we can evaluate the exact way that geometry is acting with the material that we're being used, get a true value on what that dimension is going to be, and then make our tool groom from there. So it's always good to, like I said, you know, as early as you can engage us as possible to let us know the intentions and goals for the project. You know, we would need to build in added time for a process like that. So it's always good to engage us on the front end so we can advise you on what route to take with that model to ensure it's a quick, easy, and inexpensive change to bring that tight tolerance area into spec.
The next question is, what colors are available for my molded parts?
So really colors is kind of an endless choice here. So we're able to custom match any Pantone color or Pantone number, or we can actually match any existing sample. So it's done through a salt and pepper process where we'll be given a letdown ratio from the colorant house that we use to achieve the custom color. So it's a one-time charge for the colorant. And that way we have that colorant stocked for any future production runs. We also work with material suppliers to create custom batches of pre-colored material to ensure a uniform color throughout the part every single time that part is run.
All right, and the last question I see here is there a minimum order quantity?
So no, there is not a minimum order quantity. Eccentric, because we do not have a minimum order quantity, we have a setup charge. The setup charge is going to range from $450 to $550 per mold. The majority of our tools will be a $450 setup. So with that setup charge, there is no minimum order quantity.
Okay, with one point of clarification, I guess, is with any mold, they're automatically going to get 25 parts with that mold creation, correct?
That's right, Mark. So included with the cost of our tooling, we give you 25 samples. That's included, like I said, with the cost as well as the lead time. So the lead time breakdown that Taylor brought up earlier in the presentation here, you know, if you order a 15-day mold, those sample parts are shipping on the 15th day.
All right, guys, I don't see any additional questions. So thank you for your presentation today. And I want to thank everyone for attending today. We will be sending out a link to the recording of this webinar within 48 hours. I'll also be sure to include the link to the white paper that I mentioned. If you have any questions about the topics presented today, you can email us at what you see on the screen at Brian Daly, bdaly@eccentricmold.com. You can also hit us up at info@eccentricmold.com. Also, be sure to follow us on LinkedIn so that you can get updates on our future webinars and blogs. Have a great day, everybody.